Hello and a warm welcome to everyone. We want to welcome you back and wish you a good morning, a good afternoon, or a good evening, depending where you are in the world. My name is Samantha from Safeopedia, and here at Safeopedia, it is our mission to support you, our EH&S professionals, operational folks, and any safety-minded individuals with free safety information, tools, and education. I want to give you a huge shout out for being here today, as well as for keeping our workplaces safe on a daily basis. Today, we are proud to present Manufacturing Gas Detection Safety. This Safeopedia webinar has been made possible today by GFG Instrumentation Inc., a preferred manufacturer member of AD Safety Network. AD, together we win. It is now my pleasure to welcome back to today's presenter, Bob Henderson. Today, Bob is going to teach you how to safely identify the hazards that you work with on a daily basis and how to determine the best gas detection solutions for keeping your workers safe. With that, I'm very grateful to have Bob walk you through the steps. All right, Bob, let's jump into it.
Thank you very much, Sam, and a warm welcome to everyone on a frosty, cold, and snowy January afternoon. I hope that most of you are in a warm, safe place. Up here in frozen Michigan, it has been a very cold week, but it's a hot topic. Today, we're going to focus on manufacturing gas detection safety. That's an interesting play on words, as manufacturing is what you do, and also manufacturing is what we want to do with regards to producing a safe environment for your workers. So off we go. This seminar or webinar is designed for end users, for people in the manufacturing world. We also typically have a lot of attendees from distributors and salespeople. So I'm going to be talking about the issues from both standpoints. For those of you who don't know, GFG Instrumentation is a worldwide company. We have manufacturing facilities, factories in 4 places around the world, including Germany and South Africa, Johannesburg, and Zurich, and here in Ann Arbor, Michigan. Ann Arbor, Michigan is where we have our factory, where we produce products that are sold and marketed in the Americas. So if you need help from anywhere between Tierra del Fuego and the northernmost parts of Canada, we're the folks that you come to. Our headquarters on a worldwide basis, by the way, is in Dortmund, Germany. GFG Inc., my part of the company, is a US corporation, a Michigan corporation, and we've been in business in Michigan since 1963. In Germany, we've been in business since 1961. The only thing that we do is gas detection. We're not distracted by any other categories of safety or apparel or any other kind of equipment. It's gas detection and only gas detection. And all those decades of existence has given us a chance to have a really extensive line of products, supported sensing technologies, platforms, and that means that we are able to tackle challenges and gas detection requirements that not every manufacturer can tackle. So GFG, I think it's really important to both talk about the GFG philosophy and why I think it's in many ways the best philosophy. If you're a company who cares about customers, who cares about the results for your customers, and for offering the best value, you need to take a solution-based approach to your requirements, to your business models. And that is absolutely consistent with affiliated distributors, the AD network approach, everything is focused on providing a solution, and that solution has to be um, a um, a solution from our customer's standpoint. It's not a solution at all if it's just from the manufacturer's standpoint and it's our ideas. What we need to do, what we try to do, is to find out as much as we can about our customers' requirements. And after we have listened carefully and discussed those requirements and figured out what the sources of pain are that our customers might be feeling, now we will give it our best shot and suggest the way to reduce the pain and improve the results. So, for those of you in the audience who are salesmen, don't limit the discussion to what you think your customer needs. Listen to your customer, let your customer explain, and then, based on that input, provide your opinion on what would be the best solution. And ask good questions. The more questions you ask on both sides of this conversation, the better the result. And do make sure, whichever side of the table that you're sitting on, listen to the answers. And remember that the outcome that we are trying to achieve here is the solution must be fit for purpose. I tell you what, in my 46 or whatever it adds up to years in the gas detection industry, I cannot tell you how often I have seen over those years customers winding up with the wrong product because the instruments that they purchased were not fit for purpose. They were often great instruments, but if they don't work, if they don't do a good job for the for the task that needs to be done, you just wasted a ton of money. And this is capital equipment. Even if the cost of an individual instrument is only a few $100s, if you're buying 10 or 20 or 30 or 40 of them, that still adds up to a ton of money. So I don't know about you guys, but I don't have, and my company does not have, wheelbarrows full of money that we would voluntarily want to throw away. If we have extra capital, we invest it in the company. If we don't have leftover margin, then we have to cut back somewhere. So it's good to have a proper attitude with regards to reducing waste. That is certainly a central idea behind Six Sigma methodology, the way you design products, the way you build products, and the way you offer products, in my humble opinion. GFG offers products through our exclusively through our distributor partners. And our partners are value-added resellers. One of the reasons that we're very keen on our relationship with affiliated distributors is our partners are really, really good. They provide a lot of value to our end user customers. The AD network salesmen are very knowledgeable. They're responsive. They know who to go to. And they know better than to volunteer information that they're not sure about or that might be wrong. They can bring you more than one choice. They are a loyal and fabulous resource. So take advantage. They have spent their lives becoming quite specialized and excellent with their depth of knowledge with regards to safety equipment. And anytime they bottom out on some kind of technical knowledge area, they know exactly who to go to at the manufacturers they work with. The primary benefits that I think that every manufacturer should strive for are to have great products, rapid shipment, and keep track of what your customers want. Our customers like having evaluation equipment, loaners if they need them, good field support, training. It's not fair to anybody if you have equipment that is designed for use in life critical applications to sell it and forget it. This is not this is not selling somebody a pair of tennis shoes where you can't get it too wrong. These are complicated, albeit generally easy to use instruments, but you still need to know how to use them. It's not enough for it to be easy to use the product. In our case, mostly you have one button to turn it on, one button to turn it off, but you need to know when to turn it on, and you need to know what the numbers mean and how to interpret the results. And you need to know what the heck you're going to do if an alarm goes off, which in general is to leave carefully but quickly if an alarm is sounded. And also, you want to make sure that that alarm sounds when it should sound, which means that that instrument needs to be well maintained and calibrated. So, training is absolutely essential to achieve those ends. And of course, if you buy a product, then you expect to have the service that is needed from the manufacturer over the time that you own the product. So service is a big part of what to look for. Those attitudes are reflected in our team here at GFG. I would suggest that any manufacturer that you deal with should have a team that is capable of providing the same functions. We have engineering, our applications engineers, our general engineering staff, they're all available to help answer tricky technical questions. We have sales people in the field, our own regional managers and sales directors are available. For that matter, I'm available. Our director of marketing, Paula, who is the one and only attractive individual in the slide that you're looking at the moment, is available for any marketing help, any support materials that you might need. The gentleman who is smiling at his computer screen is our customer service manager. You can get a hold of Dave Bartley literally 24 hours a day. I have no mercy going after Dave at 2 a.m. if I need his opinion on something. And the other two guys who are standing on that brown ground near the front door of the company, that would be our service manager, Steve, the shorter of the two, and our supply chain manager, Mike Fleck, who looks after ensuring that when you guys place an order, it actually goes out the door in a timely way. We not only support people from an inside the building team standpoint, but we have about 40 salesmen who work for GFG who are in the field. So there is somebody nearby, no matter what you need, who you need, when you need, just let us know and we'll put you in contact with the right person. Any manufacturer that is worth dealing with should be able to say the same things, I believe. Now, what the heck is manufacturing? It's a very broad category. The fact is that if you sell something, you had to make it. It doesn't matter if it's gasoline, you made it. If it's a car, you made it. Steel, coal, it's something that you make. And everything kind of falls into this broad umbrella of manufacturing. Industrial manufacturing includes an incredibly diverse number of hazards, of processes, of activities, and manufacturing safety managers deal with an extremely wide range of atmospheric hazards, applications, and activities. Atmospheric hazards can be generally present, or they can be associated with specific activities like confined space entry. But confined space entry is not the be all end all of what you're going to be dealing with industrial manufacturing. It's just one very important, but it's just one application that is going to involve atmospheric hazards and the need for gas detection. And every facility has it's like Tolstoy's famous quip about families. All happy families are similar, but unhappy families are unique. Each unhappy facility needs to be individually evaluated so it can be turned into a happy, safe facility from the gas detection standpoint. So, how do you figure this out? What you should do, if it's your responsibility, is to start out with a detailed assessment of activities and risks going on under your control or at your facility, everything that might involve atmospheric hazards, and drill down to understand what is most important. A lot of times when I become involved with one of our end users after sitting down and discussing and digging around, it turns out there's a lot more going on that involves potentially dangerous atmospheric conditions than anybody understood to begin with. So this is the time to figure it out. And you also need to know not only what the hazards are, but is what you are doing about the hazards meeting all requirements? Because requirements change. For instance, if you were dealing with benzene exposure a couple of years ago, the exposure limit, the TLV for benzene was a lot higher than it is today. Just last year, the new benzene limit went into effect. The new limit has an 8-hour time weighted average exposure limit of 0.02 parts per million. That's 20 parts per billion. And that can be very challenging to make sure that people are not exceeding the concentration limit, and also that you have the equipment that you need to have to make that assessment. So requirements change, and knowing where the requirements have changed helps you understand, or which requirements have changed, helps you understand where you might need to be needing to make improvements. And remember that gas detection issues are not necessarily limited to safety. You also have process control issues in manufacturing. You have process related hazards. You have facilities protection. And by the way, the solutions are not limited to portable instruments. Everyone tends to think about portable instruments first, but many times the better solution is a Sentry fixed detection system that works 24 hours a day, 24/7, every day, all the time, to make sure that anyone who enters the area is always going to be alerted under all circumstances if something happens and conditions change. So don't overlook the option of installing a fixed system. So just a quick list of all of the types of safety and hygiene gas detection. And this is just a few of the major types or major activities that are associated with atmospheric hazards. There's a lot more than this, but these are some of the major ones. There are hazards that are associated with the actual manufacturing process. If you're at an automotive battery manufacturing company where they're making batteries for electric vehicles, you're dealing with some pretty toxic materials. And if you have some kind of a spill, the electrolyte hits the floor, the electrolyte hits a little bit of water somehow, you can produce very dangerous toxic gases, which include not only combustible gases like hydrogen, but include very, very deadly toxic gases like uh, hydrofluoric acid, HF. You have manufacturing activities that can produce atmospheric hazards. You have equipment that needs to be um, installed that can control the process if something goes wrong. For instance, if you have an internal combustion process that might generate carbon monoxide or SO2, often you need to not only guard against people going into the area, you can guard against individuals going into the wrong place at the wrong time by assigning them a personal portable instrument. But you also want to have a system so that if you exceed a take action concentration, maybe the fans come on. If the concentration continues to rise, maybe along with the fans, you now sound the alarm. If the concentration continues to rise, you're not only going to evacuate the facility, but you're going to notify the local fire department and emergency response groups. So there is a calibrated series of take action levels that are based on the concentration of what you're measuring. Sometimes you tie the readings from your gas detection system directly back in to the production equipment and shut it down on the basis of the reading. If you have a refrigeration plant and you have an ammonia leak, one of the things you're going to do is to shut that down until you deal with the leak. So these are all decisions and capabilities that flow from the system used to measure the atmospheric hazard. So you have facilities protection, you have safety monitoring, you also sometimes have industrial hygiene and personal exposure limit monitoring. It's not enough to keep your workers from dropping like dead flies because the concentration is suddenly very high of a particular toxic gas. You also need to make sure that the concentration, the exposure, does not exceed the statutory or regulatory exposure limit for that gas. And those limits are getting lower all the time. And of course, you do have confined space entry going on. That is a big part of what happens on a day-to-day basis at many industrial manufacturing facilities. You go to whether it's a pulp mill or a semiconductor plant or a steel mill or a refinery or any place that they're making something on an industrial scale. Boy, you look around, you see a bunch of confined spaces, and often these confined spaces are being entered on a very regular basis. Sometimes it's a very discontinuous kind of situation where the only time that you have a lot of confined space entry going on is during a shutdown or a turnaround. The other end of the spectrum would be places such as a commercial food production facility where everything is done in an incredibly cleanly, hygienic way, and you prepare the food, you prepare the edible stuff in tanks and vessels that need to be cleaned after each batch. And people have to go in to the large vessels to do that. And you'd better be monitoring for the atmospheric hazards that are associated. And often there are a lot of those. And it's a little bit different how the hazards come into existence. With many food production facilities, the process includes fermentation. That would be true of the use of yeast in making bread. Um, and it would be true with facilities where they're producing biofuels from grain or corn. It's true from facilities where they are brewing beer or distilling hard liquor, my favorite being bourbon. Uh, and you definitely, anytime that you have fermentation going on, you have a lot of carbon dioxide that is being produced by definition. For every one molecule of alcohol that you produce two molecules of carbon dioxide. Carbon dioxide is really, really heavy. It's 150% the density of fresh air, and it tends to collect any place that it can collect, either inside a confined space or often near the confined space. Where it collects, it can displace the oxygen and you can have problems. So, again, often the best approach is to install a fixed system as well as use of appropriate personal portable monitors. And often you need both. There is nothing wrong with having a belt and suspenders approach. That's often the optimal approach. Construction, turnarounds and shutdowns are one kind of construction related activity, but often you're building a new section of factory. You're building onto the existing plant, you're tearing down the old plant, you're putting up a new plant. Construction introduces all sorts of additional hazards. Hot work, welding, brazing, uh, grinding, anything that introduces a source of ignition into the environment introduces additional hazards. And that is particularly true when the hot work occurs in a confined space. You also, as a manufacturing manager, your factory is sitting somewhere, often in the middle of a community, and often there are issues with monitoring for atmospheric conditions at the fence line or for nuisance odors. What you don't want is the nearby neighbors to go complaining to somebody who then turns up at your site ready to shut you down or to impose a cease and desist order. So you're a lot better off taking action when it's the tiniest whiff of a bad odor than when you've got a plume of high concentration gas moving towards the nearby civic center. So fence line and nuisance odor systems are also very important. You have disaster response. Um, if your facility floods, we've seen in the last couple of years some truly dreadful hurricanes that have hit the southeast and flooded vast areas. And when a factory or a refinery or a chemical plant is flooded, you better have gas detection as part of your emergency response. And of course, just flat out the equipment that your people are going to use if there is an emergency going on has got to include gas detection. It's going to include a lot of other kinds of equipment, safety equipment, such as fall arrest and retrieval, PPE, all sorts of different kinds of response related equipment. But gas detection is the one of the tops of the hit parade here. You definitely can't conduct an emergency response at most industrial facilities without including gas detection. Why are there so many hazards? You use all sorts of potentially toxic materials in our modern world when you make something. Um, Materials that are used in production that can wind up producing atmospheric hazards include resins, sealants, polymers, solvents, degreasers. You use a lot of industrial process gases. Gases include things like um, natural gas, nitrogen, argon, sulfur dioxide, chlorine, hydrogen. If you're in the semiconductor industry, holy smoke, do you use a lot of toxic gases? What you do in semiconductor manufacturing is you etch the silicon wafer and then you dope the wafer with gases that lay down um, semiconductor materials such as um, arsenic and phosphor and all sorts of other substances. And to get the material deposited, you're using gases such as silane or arsine or phosphine or hydrochloric acid or hydrofluoric acid to do the etching or nitrogen trifluoride. These are deadly gases. And if you have a leak, you don't want to be nearby. So you're going to need to measure these hazards or be looking for these hazards so you can do something if you do have a leak. You have refrigeration gases. That includes ammonia nowadays, since there is a concerted effort being made to avoid use of ozone depleting refrigerants such as freons. They're being replaced with other gases such as propane. Freons are still used in sparingly, cautiously. Nitrogen, another refrigerant gas. Um, and you have a lot of chemistry going on, better living through chemistry when you're transforming raw materials into finished goods. You have all sorts of chemical reactions. You have curing and drying process and procedures. Everything that's going on somehow seems to involve gas detection or the need for gas detection. To an extent, that's, a carpenter with a hammer sees nothing but nails, right? You've heard that story before. And from my standpoint, since I've got a bag of gas detection hammers, the world looks like a nail. So you could fault me for that, but I'm not wrong. The world is full of nails from my standpoint. So you have chemical reactions, the kinds of chemical reactions that are associated with atmospheric contaminants. You can have synthesis going on. You have electrolysis, sulfurization, where you're deliberately using something like SO2 as the process gas to achieve the desired reaction, hydrogenation, doping. And remember, Doping is not hiring the guys in Bill and Ted's Excellent Adventure. Doping is the actual deliberate use of aggressively hostile gases, often hydrides like arsine or phosphine or silane, to lay down a thin layer of atoms on a silicon wafer. You have fermentation, already mentioned that. You have often your rupturing molecules, decomposing them to turn them into smaller blocks and then recombining them into something else that you're actually going to sell. Oxidation can also be accidental. Rusting is oxidation. Rusting can be an excellent way of creating an oxygen deficiency. With confined space entry activities, don't forget, you have especially increased the hazard level if you have hot work procedures going on. Anything that alters the confined space, such as scraping down the inside of the confined space, mucking the confined space, which involves stirring up whatever residue is and removing whatever residue is in the bottom of the confined space. If you're applying paints and sealants in the confined space, that also presents all sorts of additional potential atmospheric uh, dangers. Some of the specific things when you're wandering around your plant or talking to your employees, or if you're a salesperson talking to your customer, be on the lookout for battery charging areas, which are often associated with the generation of hydrogen, combustible liquid cabinets, gas storage areas, the potential for spills, the potential for leaks, fueling stations where you're replenishing equipment that is powered by hydrogen or propane, where you have combustion going on, you have absolutely the potential for atmospheric contaminants, stack gas, SO2, acid gas, NO2, NO, CO, CO2, engine exhaust, CO, NO2, NO, CO2. Sometimes you're deliberately creating dangerous atmospheric conditions as part of the manufacturing process. You may need to purge the area or the vessel with nitrogen to make sure that nothing is going on which will expose the product that you're trying to manufacture to oxygen. So you have nitrogen purging, you have curing ovens where the curing occurs under a nitrogen purge. You have inert gas actuation at a foundry. Often a big blast furnace is going to be actuated with argon. You have shielding going on often in large generators and dynamos where hydrogen is used. It's interesting to think all of those spinning energy generating components are doing their job in a shield of pure hydrogen. But that's the way the dynamo works. So there's just a lot of things that can involve dangerous atmospheric condition due to leakage or to something going wrong. So it's fun for me to talk about all these issues in broad strokes, but that's kind of a daunting task now if you're the person who's in charge of figuring out what's needing to be done and then doing it. So one of the things that I would urge you to do is take an organized approach. When you're getting ready to think about buying or specifying a gas detection instrument or system, the first thing that you want is a statement of purpose. Make sure that you clarify even to yourself what it is that you need to accomplish. So the statement of purchase is not a multi-page technical specification. It's a simple and brief but complete description of the goals for detecting the hazards or condition. So, if you are fulfilling an obligation that is defined by a statutory requirement, such as for permit required confined space entry or confined spaces during construction activities, then make sure that whatever you're going to do satisfies the regulatory requirements. There are a couple of really useful resources that I would suggest that you have a look at. The AIHA has some, that would be the American Industrial Hygiene Association, has some marvelous resources that are available for downloading. They have a technical framework document, which is a guidance on the use of direct reading instruments that specifies what you need to know, what training you need to have in order to use gas detection equipment. Very useful if you're wondering, okay, now I buy these things, how do I use these things? That is a marvelous resource. You can either go to the AIHA website and download a copy, or if you have trouble with that, you can give GFG a call and I'll come up with a link that you can use. And you also have nice documents on the AIHA site, such as a white paper that tells you the process to use when you're figuring out what alarm points to use and what to do if you find the presence of a contaminant. So this tells you how to understand the monitoring target, things that you need to consider when you buy an instrument to ensure that it's actually going to be operable for use in the environment, the knowledge of environmental conditions that could affect your ability to use the instrument, human factor considerations, what to do with the alarm information, and to verify that the instrument meets certification and use requirements. So that's a lot of stuff. If you didn't need to figure it out, or if you needed to figure it out on your own, you'd have to do what my AIHA Real-Time Detection Systems Committee did. We had a group of about 6 experts that spent 2.5 years figuring out the protocols. So you don't need to reinvent the wheel on this. You can download a copy of the white paper and you'll see everything spelled out in a step, spelled out. Spill, that would be a Freudian slip. I can keep going. Anyway, when it comes to our part of things as a manufacturer, we are going to supply or suggest, hopefully suggest and supply the gas detection solution that you need to fulfill these objectives once you know where they are. We have a really wide variety of gas detection equipment and options, which is why it's going to be better to figure out what you need before you go on a shopping expedition. Of course, you can simply talk to your friend and helpful resources at your affiliated distributor of choice, and they can take you through the process as well. These guys deal with these hazards every day of the week, and they have a really high level of knowledge. And of course, the manufacturers that they work with are always in the background. We're immediately available if our partners need help. And the way that a good company sees this issue, I think, is we see everyone as a customer. We see our end users as customers. We see our distributor partners, our value added resellers as customers. If everybody is a customer, or we would like them to be. So your basic confined space instrument, still the most popular multi-gas instrument, is the simple one with 1 to 4 sensors. For confined space entry, minimally, you're going to have to measure oxygen, H2S, CO, and explosive gases. And they tend to be simple, not very expensive. In our case, we have interchangeable alkaline or rechargeable, safe rechargeable nickel metal hydride batteries. And we pride ourselves on cost of ownership and having the lowest cost of ownership of anybody in the market. There is a difference between the the purchase price and the cost of ownership over the life of the product. So you buy a product, you have a product, you're going to keep the product for a certain length of time. In our case at GFG, I think a wise decision is to keep it in service for a long time. I'm a little bit opposed to throwing something out after 2 years. Partly that comes because we're a worldwide company and we sell products in Europe as well as the United States. In Europe, you are constrained. Officially, the rules prohibit deliberately manufacturing a product that winds up in a landfill somewhere. You're supposed to build products that can be reused or recycled and don't wind up causing long-term harm to the environment or winding up in a trash heap somewhere. So what we like to do at GFG is replace sensors, replace batteries, refurbish equipment, and keep on going. We offer lifetime warranties on the electronics that don't wear out with time. I think that is a good point that you should look for. Look for the warranty support and life of the warranty on the sensors. The sensors are one of the items in the instrument that will need to eventually be replaced at some point. So you should find out what the replacement cost is going to look like and how long it's going to take before it becomes necessary. What we like to do for our products is put together refurbishment kits where we include a set of sensors, a new housing, a new battery pack, so that after the refurbishment is implemented, you have essentially a brand new instrument. It's an instrument that carries the same warranty as an original, freshly purchased instrument. So if you have a product that is designed for periodic refurbishment, you can wind up with a product that instead of having to chuck it after 2 or 3 years, you can keep it for 15 or 20 years. And it's going to be as functional and fit for use after 20 years as it was after 1 year, if it's designed for that objective. If it's designed to be thrown out, then you're going to have to throw it out. And probably it's going to cost you a lot more for all those replacement instruments over 15 or 20 years uh, that than it was that you saved by buying a cheap instrument on day one. So we have basic four-gas instruments, but increasingly, four-gas is not enough. The fact is that in many cases, the specific toxic exposure limits for other gases that might be present that you used to overlook, you really can't overlook anymore. One of the biggest categories would be volatile organic chemicals. Many confined space entries are now being done with a five gas instrument that includes a photoionization detection sensor, a PID sensor, as sensor number five. VOCs are explosive, but long before you get to the point where it shows up on the explosive scale, you exceed the toxic exposure limit. And you have to look at it in ppm, not LEL increments. Well, if that's what you need to do, it's easy. You just need to have the right instrument. Sometimes it's SO2. If you have a lot of H2S around and you're using the instrument, among other things, for atmospheric monitoring during hot work, H2S plus hot work, you're going to get some SO2, and the exposure limit for SO2 is very, very low. If you're using diesel equipment, diesel engine equipment in a confining environment, or even just standing nearby in the wide open near the place where the exhaust is being vented by the equipment, you have plenty of NO2 being generated. NO2 is really, really toxic. And one of the problems with a gas like SO2, you might not start out being sensitized to it, but with chronic exposure, you can get to the point, and I think I've just visited too many mines and too many foundries and calibrated too many NO2 meters. Just a tiny little bit of NO2 brings on a coughing attack to me because I'm sensitized, and you don't want that. So your exposure limits are nowadays low enough that they guard against workers becoming sensitized. So there are a whole lot of additional sensor combinations that might be exactly what you need. If you go through the process that I've suggested, you'll find out if you need five sensors, six sensors, or more. You also need to decide how you are going to operate the instrument. Are you going to use it in diffusion, or are you going to use a tube and a sample probe to bring a sample to the sensors from a remote location? And if you need that capability, then you need to have an internal pump or an attachable pump. In this case, in the instrument in the hand, we have a built-in internal pump, and we have a switch which you can slide from one position to the other. When you slide it upwards, you turn the pump on, and then the sample is coming entirely through a hose and probe assembly. When the switch is in the other position, it's being operated in diffusion mode. There is more than one way to skin this particular cat, but make sure that you think about how you're going to do that. If you don't have a pump, you're going to have to do things like putting the instrument on a lanyard and dropping it into the confined space, or otherwise taking it into the area where you need to measure the contaminants. If you have a pump, then you're going to pull the sample through a hose and probe. In the case of this instrument, we have an attachable pump. In the case of this instrument, we have an internal pump. So whatever your heart's desire, it's available. Um, Heart's desire, again, whatever you need, chances are you can get if you know that that is a requirement. One of the big um, buzzwords at the moment is wireless and wireless communication. If you need to be able to communicate remotely in real time with a computer or a server, um, you can have that. You just have to specify that you want that built into the monitor. In this case, we have a wireless server that can control and display information flow for up to 10 instruments at a time. And the instruments themselves have wireless RF transceivers that are capable of talking to this remote server or to a computer someplace else. Once it's in the computer, it can go to the cloud and wind up anywhere else it needs to be in real time. So the idea with wireless communication is the information you need wherever you need it in real time. So you get there by specifying your desires before you buy the instrument. Fit for purpose really requires sensors that do the job they're supposed to do. The company that you deal with, if it's a gas detection company, should have control of the sensing technology. That's a real specialty and an important part of GFG. Our oxygen sensors, our preferred oxygen sensor, is warranted for 5 years and is expected to last for even longer than that. And it's also leaving out the lead. It's a lead-free sensor, so it's not as great a toxic concern if and when it's time to throw the sensor out. We manufacture an increasing percentage of our sensors ourselves. Our sensor manufacturing unit is in Germany. We also build sensors in Ann Arbor, Michigan, in our case. So we really do have control of the most critical element in the instrument design, the sensors. Sometimes it's a single sensor instrument. Those are available. In our case, we don't like instruments that don't give you a real-time reading. All of our instruments actually show you what the current concentration is and provide an accurate real-time reading. You can have a single sensor, you can have two sensors, you can have four sensors, you can have up to 7 channels of gas detection in the same instrument. And because we have control of the sensing technology, we're able to measure some really difficult to measure gases. For instance, one of the company specialties at the moment is hydrofluoric acid measurement. We do quite a bit of business with battery manufacturers, fire departments, other places that deal with lithium ion batteries. If you have a lithium ion battery fire, you're going to be dealing with HF whether you want to or not. In terms of fixed detection, don't rule in or rule out fixed gas detection until you've thought about it a little bit. When the hazards are chronically present, a fixed solution is probably something that you should think about. If the same hazards crop up periodically in the same place, definitely at least think about permanently installing a monitoring solution to go along with the use of portable instruments. If the activities which involve the exposure are tightly regulated or governed by a permit like confined space entry, then a portable solution is probably a better solution. And don't be afraid of considering fixed system options. Not all fixed systems are gigantic 30, 40, 50-point systems. Most of the systems that are in use out there tend to be a little bit smaller, often 1 to 4 points of detection, or even a single point standalone system. If you have one hazard in one spot, it's actually very easy to deal with, often with a fixed detection system. But before you go down the road too far, make sure you understand not only the application, but the company's attitude. Are they going to insist on an external design firm? Are they going to require you to take a uh, a committee approach that includes other departments around the site? Often with a fixed system, it's not exclusively a safety department decision. It's going to include facilities, production, hygiene, safety, finance, and it might include individuals from other facilities or at other levels in the organization. With a fixed detection system, trust me, the easiest way to ensure that you come up with an optimal solution is go to the manufacturer of any brand of fixed detection equipment that you're thinking about. We all have a simple questionnaire form that you can fill out to help clarify what you need before you get to the point of requesting a bid or issuing an RFQ. For every minute that you spend filling out the questionnaire, you're going to save 30 minutes of coming back redundantly and fine tuning what you wind up purchasing um, with repeated attempts to get it right. Get it right the first time. Measure twice, cut once is great advice. Fill out the questionnaire is even better advice. So this would be an example of the absolute simplest type of fixed system. Here you have a transmitter. That's the actual sensor and the associated local electronics. In this case, you're simply terminating the transmitter to power. It has a built-in display, a built-in alarm. If all you need is the number and a local alarm, you're golden. If what you need is to control external equipment or network a bunch of transmitters, then you probably need a controller as well as a transmitter. So more on that in a minute. Sometimes the transmitters need to be installed in a hazardous location, and you have to be guarded against the transmitter being the source of ignition. You can do that in a couple of different ways. You can use explosion-proof transmitters, where if there is a release of energy, it's trapped in an explosion-proof housing, or you can use an intrinsically safe transmitter where it's designed in a way that prevents any possible discharge of energy sufficiently high enough to be the source of ignition. Sometimes you want the sensor built into the transmitter. Sometimes you want the transmitter on the end of a cable. Sometimes you want the transmitter to have a built-in pump. These are all available. And from the standpoint of features like a display or not a display, we're working on a 1,300 point system at the moment where the solution is going to be winding up with a blind transmitter that does not include a display or push buttons. The PLC, the programmable logic controller that the customer is using or will be using, is where the information is shown and where the the transmitter is controlled. So the kinds of gases that we measure that might need to be measured, I've got a list of over 500 analytes that we frequently get called in on uh, to measure and take action against. One of the things that makes that more easily possible is our system and other manufacturers also. We're not the only one on this. You build the sensors with local electronics right on the sensor that communicate with the controller and tell it what kind of sensor, how to interpret the signal. And the controllers themselves are really sophisticated. And as long as the transmitter, as long as the sensor and local electronics has an output that can make sense to the controller or PLC, it doesn't matter what brand it is or what kind of a transmitter it is. It can be a flame detector or a smoke detector or a gas detector or a pressure meter. It can all communicate with the controller, and the controller can show you the results either on a local display or on a computer display. And the complexity of building one of these is immense. Hundreds of thousands of lines of code on the inside of the controller. But from the standpoint of using the controller, it's pretty simple. Just plug it in, calibrate it, um, get some help from the manufacturer. I'm sure you'll appreciate that. And ultimately, what you have is a real-time display that shows you the monitoring results. Now, some advice, some good advice is don't focus exclusively on price, at least not early on in the evaluation and specification process. Once you have completely identified the requirements and objectives and benefits of the equipment, now you can look at the price and decide, well, do I want to go for something that has the lowest imaginable initial purchase price, or do I want to make the calculation based on the fact that I'm going to keep the product for 6 or 8 or 10 years? Make sure you understand the costs before you make the determination. For instance, under the cost of ownership headline, are you spending a fortune on keeping your current equipment in service? Are you paying a monthly fee? Are you having sensor replacement issues, battery replacement issues? Do you do all the maintenance yourself? Do you farm it out to a third party? Is that expensive? And are you feeling like you're currently getting a good deal? And remember to think about who is looking after your instruments now and who will be looking after your instruments in the future. One of the nice things about AD distributor partners is many to most of them have a service department where they can give you a hand with your overtime requirements. And these issues just become more and more important the closer you are to replacing or augmenting or expanding your fleet of instruments. And do make sure that you're staying current with monitoring requirements and the next generation of instruments that you purchase is capable of doing what needs to be done. Pay attention to the kind of batteries in your product. There are 3 options nowadays for batteries. You have alkaline batteries, which are low hazard, not toxic, but they can't very well be used when the conditions are very cold, and it can get expensive when you replace them on a regular basis. We offer alkaline batteries as an option for some of our instruments, and it makes them very attractive to some of our customers, especially contractors. For our rechargeable batteries as a company, we have chosen not to use hazardous lithium ion batteries. We use nickel metal hydride batteries, which means it's not a hazmat when it comes time to shipping the instrument, either back to the factory or anywhere else. If you have a lithium ion battery, it's not only the aircraft issue of taking it with you when you fly somewhere. Um, you can't even ship it by ground transport without filing hazmat paperwork if it's a lithium ion battery. You have to keep it in your personal possession. If you do fly with the instrument, it goes with you in the cabin, not in the hold with your baggage. If you have requirements for your workers to perform a daily bump test, make sure you give your workers the equipment to allow them to do it. They're going to need a bump test kit or a cal kit. And if you have a bunch of instruments or even a few instruments, probably you want to invest in a docking station that makes calibration, service, and maintenance a whole lot easier and a lot closer to automatic. And remember, this is important life critical equipment you deserve after the sales support. And that's one of the things that you get with affiliated distributors. I can't say enough great things about the AD organization. It's not just training and webinars, it's a team of individuals who are really there to help you get the job done. And if you want additional information, please visit the gfgsafety.com website. Make sure that you, at the end of the URL, you do indicate US-EN. We're an international company, and we have all sorts of different language versions of the site. You want the United States English version, please. Yeah, I don't want to hear that I have offended somebody when the website that they wander off to turns out to be communicating in German or or Dutch. So, let alone French, unless you're in French Canada. But anyway, we do have multi-language support. Questions from anybody? I'm here. I'm always available. Please give me a holler anytime that we can be of service. And thank you for signing in for today's Safeopedia webinar.
Well, Bob, thank you again for being here and always giving us a wealth of information. We always appreciate it. I encourage everybody to head over to GFG and make sure you do choose the correct language and reach out to Bob. There's the contact on the screen, the numbers on the screen. Make sure that you're reaching out and you're getting all of your gas detection needs met. I want to thank you again, Bob, as well as GFG Instrumentation Inc. and AD Safety Network for allowing you to be here today, because we really appreciate it. And of course, I want to thank all of our dedicated safety professionals for keeping our workplaces safe and being here today, because without them, none of this would be possible. So thanks again. Take care and stay safe. Bye, everyone.
Thanks, guys.